Hey guys, welcome to Codeforces Everyday Until GM, day 43. Let's just jump straight into solving. IQ test. Starting off with a 1200 rated. Turns out there's another problem called IQ test that's... Wait, have I already done this question? Why isn't it marked? 287? Huh? This one's rated 1300. Wait, hold on a sec. Codeforces. It's another one of these situations where the problems are named the same thing. Okay, I might have to go back and rename all my files. You know, I really liked having this naming convention, but this is the second time where I've ran into a duplicate name, and it's just kind of a pain. Okay, let's delete this. Go into my settings. CPH. Use a short name. So I think I'm gonna go back after this video and regenerate all my CPH files, and basically the name of the files will just be 43A blah blah blah, and then inside of the hashtag, the rating hashtag, I'll put the actual name of the problem, so then I can still search by the actual name of the problem with this thing, and I'll never have like conflicting file names again. A little bit annoying. I wish they would add an option in CPH where they allow like a combination of, you have the ID and the name of the problem together, but I don't know. That's kind of up to them to add. I've made an issue about this like a little while ago. I don't think anybody has looked at it. This is my bug report of like duplicate names. I don't think anyone has looked at it, so that's a little bit annoying. But yeah, for now, I'm just gonna regenerate these. It's gonna be a pain, but whatever. Little bit disappointed. Oh, I generated the wrong one. I'm not doing this one again. Nope, 25. Hello? 25, you're going bye-bye. CBH, you're gone. Go here. Click this. Yes, and then I don't have... Yeah, okay. This should be fixed now. So annoying, but okay. It is what it is. So I guess I'll format it like 287A IQ test. Like ID and then IQ test, and then the rating is 1100, and it looks like I have my autocomplete on because I was coding other stuff today. Settings, inline suggests enabled. This one. Yeah, okay. Let's get started. That was a drag of the first 5 minutes of the video. Well, in the city of Ultima Thule, job applicants are often offered an IQ test. The test is as follows. Person gets a piece of squared paper, 4x4 square painted on it. Some of the square cells are painted black, others are painted white. Your task is to repaint at most one cell the other color so that the picture has 2x2 square completely consisting of cells of the same color. The initial picture already has such a square. The person should just say so and the test will be completed. Task is write a program that determines whether it's possible to pass the test. You cannot pass the test if either repainting any cell or no action doesn't result in a 2x2 square consisting of cells of the same color. 4 lines to... Okay, wait, what? What is this saying? We have a piece of squared paper. Okay, you know what? I am going to include the link as well. Just because CPH doesn't actually work across devices. Like I push this up to my GitHub, but when I pull it doesn't generate this thing for it. Which is weird. I don't know why. So I'll include the link just for my personal. It's gonna be so annoying. I have to redo 175 problems. Just go back, repaste the same 3 lines, but I have to change it up each time. Oh my god. Okay, whatever. Let's focus on the question. Each person gets a 4x4 squared paper painted on. Some of the cells are black, some are white. Task to paint as most one cell so that the picture has a 2x2 square consisting of same color. If the initial picture already has, just say so. Write a program that determines whether it's possible or not. You cannot pass if either repainting any cell doesn't result. Okay, so we need a 2x2 square. How can we track this? Let's get a whiteboard. Two x2 square. Well, okay, so since the sample size is small, we're confined to this 4x4, we can just brute force, right? We look through the first line. Find the first group of 2, and then check the last 2 under it. If it's 1, print yes, else print no. Wait, if it's 1, print yes. If it's 2, print yes, else continue. And we look through the next. Doesn't seem that bad of a problem. It's just a brute force problem. Okay, so what are we taking in? Square or paper. Okay. 4. Let's check that I'm importing this correctly. Does seem so. Now, what I basically have to do is for row in paper, or in range for call in range for if row, okay, wait. Or in column 0, row 0, if row no if call wait, let me think. Let's do R and C. Row column so if paper row column equals paper row plus 1 column, print index out of range if R plus 1 is less than 4 and 0, 1, row plus 1. We're in the same row. It's call plus 1, print it's call and call plus 1. There we go. So work it 0, 1, 1, 2, 2, 3. This one just 2, 3. 0, 1, 1, 2, 2, 2, 3. Yeah, 0, 1, 1, 2, 2, 3. So this is working fine. Now we just check if r plus 1 is less than 4 and paper r what paper RC is equal to r plus 1 or this. We'll print yes, break, yes, exit, print no. Index out of range, why? Diamond in the rough. Print RC. Zero 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 one 02 03 10 12 13 10 11 1 or 2 3 3 0. Else break. Okay, it's because when we hit one of these, okay, so what we can do is set a flag. I did not mean to do that. when we hit one of these out of bounds conditions, we break. And then wait a minute. Can't we just like cut it off at like 3-3 and we don't even have to worry about out of bounds? That's smart. Why didn't I think of that? I can do I in range 3, C in range 3. So 0, 1, 2. And we won't even need these row call checks, right? Allegedly. Alright, 0, 0. 0, 1. 0, 2. Yeah. And then RC plus 1. Well, I know what C plus 1 is. It's 0, 1, 1, 2. Okay. So this should work. Any edge cases? I guess I should check a case where it's like TIS. Yeah, that works. Now let's just submit it. Wrong answer. On test 24, what could that be? I guess a case where it's all empty? Or where it's like alternating? Or I don't even know. Alternating the last one. Oh, I didn't even think of this case. I give no, but it's yes because of here. Because we're looking at these first. We're checking these. No, it doesn't exist, doesn't exist, doesn't exist, doesn't exist, doesn't exist. Doesn't exist, and then it exists. Da, 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 da. I'm trying to think if bottom row is the only row that behaves like this. Okay, let's consider a test case where it's like this. Wait a minute. Got it, this guy has to be hashtag. And then I'm trying to isolate like a group like this, but it's kind of hard. This prints no. Expected output is yes. So the easiest fix to this is we just reverse it and check it again. Or we can duplicate the if statement to check for upper as well. RC we don't need this again, we just have this part. Row -1. Okay. Passes this case, it still fails this case. Why? Zero, 1, 2. 0, 1, 2. So we only look up to here. +1. And then the... Okay, so we only look up to here, basically. So what we want to do is put C back to 4, and if C +1 is less than or equal to 0, 1, 2, 3, and so we're looking at row 2, 0, 1, 2. No, this goes back to 3. Row goes back to 4. Don't need this. Zero, 1, 2, 3. 0, 1, 2, we check this. R is 3, R minus 1 is greater than 0, yes. What are we outputting? Index out of bounds error. Line 13. Here. If R plus 1 was less than or equal to 3, and still getting index out of bounds. Why? R is 3, R plus 1 is 4. 4 is greater than 3. Are we failing here? No. Here 1. We don't enter any of these. We don't even print no. So what do you mean? Else? No. There's quality debugging right here. It doesn't hit any of these at all. It just goes here, breaks on this. Okay. Can just do this. Okay, that worked. A little bit annoying. But the print statement here. Let's kill that. Passes all the tests now. Should be able to submit it. And we got it. Took a little bit long, 30 minutes. Found the solution in roughly 10-15 minutes. Then another 10-15 minutes of debugging. A little bit slow. Slow pacing for 1100. But we got it, which is good. Okay, building permutation. So let's do dot A, so I can just copy like this, paste, then copy the link, and then rating 1200. Say this. Permutation P is a ordered set of integers from 1 to n, consisting indistinct or P1 to, okay, it's not 1 to n, it's like P1, P2, but they're in order. Consisting of indistinct positive integers doesn't exceed n, we denote ith element of the permutation P as Pi. We'll call number n the size of the length. You have a sequence of integers a1, a2, all the way to an. In one move, you're allowed to decrease or increase, count the number of moves needed to build a permutation from the sequence. So n equals int input. A equals, let's map int input split. So in the first sample, you should decrease the first number by 1, increase the second number by 1. The second sample, you need 6 moves to build 1, 2, 3. What are we trying to do? A permutation P is an ordered set of integers P1 to P2, Pn, consisting of n positive integers, each of them doesn't exceed n. We'll denote that the ith element of the permutation P as Pi and call the number I don't really get the point in P. It kind of just sounds like you want a collection of 1, 2, 3, 4, 5 to n or whatever. Let me think. Minimum amount of moves you need. Three O. So if you sort it, it's 03. Move this to 1. Move this down to 2. And this 2. Okay. -1, -1, 2. It's already sorted. Move this up to 1. Move this up to 2. Move this up to 3. 1, 2, 3, 4 moves. 6 moves. This requires 2 moves. 1, 2, 3, 4, 5, 6. Okay. I think this is just the solution then. It seems pretty simple. You just sort it in one pass. a dot sort, and then we can have b equals range 1 to n plus 1. Whatever, just run it here. List. Okay, so what we can actually do is something like for p in range 1 to n plus 1 to print equals 0 to print plus equals p minus a p. Find range n. P plus 1 minus AP so we're doing if P this is 0, 1, 2. We actually want 1, 2, 3, so P plus 1 minus negative 1 okay, and then we just print to print 0. Why are we getting 0? We need abs. Okay. There we go. Got it. That wasn't so hard. That was much easier than the previous question. Would you look at that? One more problem? Okay. Binary search problem number theory, 1300. We know that prime numbers are positive integers that have exactly two distinct positive divisors. We can call a positive integer t prime if it has exactly 3 distinct positive divisors. You're given an array of n positive integers for each of them. Determine whether it's t prime or not. Okay. N equals int input. What the? X equals okay. Prime numbers are positive integers that have exactly 2 distinct positive divisors. We call a positive integer t prime if t has exactly 3 distinct positive divisors. You are given an array of n positive integers for each of them. Determine whether it's t prime or not. Print in lines. The ith line should contain yes without quotes if t prime. Okay, what is t prime? If it has exactly 3 positive divisors. So 4 has 4, 2, 1. 5 is prime. 6 is 6, 3, 2, 1. Okay. I get it. The question is, how do we actually calculate this? If we just count the divisors, that would be too slow, right? Can we use DP? Ten to the 12th. It says binary search, implementation, math, number theory. 1300 rated problem. Binary search. So I'm thinking of something like say we use this example here, 4. We go from 1 to 4, midpoint 4 divided by 2 is 2, and then 2 divided by 2 is 1, so that's 3. If we do 5, 1, 5, 5 divided by 2 is 2.5. Do we seal it or floor it? Okay, let's take a look at case 6 first. 1, 6. 6 divided by 2 is 3. 3 divided by 2 is 1.5. Seal it. So it's 2. I guess we seal it, so it's 2.5, so it's 3. And so what we do is we check the midpoint. If we've already seen the midpoint before we end, and if we haven't seen it before, we check, we like do the number mod midpoint, and then if it fails, then well, we only need to check 3 digits, right? So okay, we only need to find one more. So what's an odd number? Let's try something like 15. 1, 15. 15 divided by 2 is 7.5. Round up to 8. 8 doesn't work. So then we do 8 divided by 2 is 4. 4 doesn't work. 4 divided by 2 is 2. 2 doesn't work. How do we actually binary search this? Like, I don't see it. I don't see what I'm supposed to be doing. What? What other... Like, I'm thinking about just like brute force, but n squared 10 to the 12th can't really brute force that. Four is yes, 5 is no, 6 is no, 7 is no, 8 is 1, 2, 4, 8. No. 9 is 1, 3, 9. Which is yes. 10 is 1, 2, 5, 10. Which is no. So if it's a multiple of 2, it's auto no, right? Because it's if it's a multiple of 2, unless it's 4. If it's a multiple of 2, it's at least If it's a multiple of 2, it's at least 4, because it's 1 itself, and then 2 times the multiple. So that cuts out all the even numbers. Even numbers can't be t prime unless it's 4. So, okay. Well, what do we have? We have 4, 5, 6. What did we try? 4, 5, 7, 8, 9, 10. Kill all the even numbers. Kill 7. Kill 5. So 4 and 9 are the first two t prime. What is 4 and 9? 3. Okay, 3. Multiples of 3. 3, 6, 9. 9 is the first. This 12 is 3, 4. 12 is even. Next one, 15 is 3, 5. 1, 5. 1, 3, 5, 15. So that doesn't work. 4, 4 wouldn't. Would 4 have one? 4. Or so we're at 1. It'd be 1, 4. No, it's not, because 3 times 3 is 9. 3 times 3, so 3 squared is 9. 4 is 2 squared. 2 squared because it's 1. So okay, so here's a pattern. It's 1 numbers. Okay, it's 1 x squared n. This is the divisors of t prime. One x squared n, right? Because if you have a multiple of anything else, you'll have duplicates. X squared here can't be even, where wait, so x squared has to be prime, right? 2, 3, because 4 doesn't work. 5, it'd be 1, 5, 25, and there's nothing else. 6 wouldn't work, because 6 by default is 2, 3. 7, 1, 7, 49. Okay, so it's 1 prime squared n. So we basically just check I'm gonna do a quick restroom break. Be back in like 5 minutes. Okay, I am back. It was kind of crazy. My bladder has like shrunk a ton since when I was like a high schooler. It's only been like 5 years, and dude, I used to eat a ton back then, but nowadays I just barely get by, you know? But yeah, I feel like I've been needing to use the restroom like so much more than I used to. Okay, where were we? So 1x squared in, right? What are we looking for again? Uh, so if it is t prime, then we print out yes, else we print no. So we're basically we have to compute each in one by one, right? So for number for num in x, like it doesn't really affect the previous. Do we have to make a seed? It's like we have to print no for every number. We have to find the largest number that fits in the seed. Da 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 da. How does binary search like fit in here though? Like I don't really. That's what's really throwing me off. Like I don't think I've done maybe one binary search problem that I actually used binary search for. But I'm thinking we just do like a seed and then we iterate for each line. Okay. Let's just go with that then. Now do I remember how to implement the seed? What I do remember is we need an array. Frick. Okay, what was that? Was it this one? No. Hungry sequence. Primes is primes. Is prime equals. Prime. So we need is prime And our upper bound is in. And then for p in range 2 n plus 1, if is prime p is true, okay, well, we need this primes array. Okay, let's try to actually build this without just copying piece for piece, so I actually remember how to do it next time. So if is prime p, then primes dot append p, and then we set all the multiples of p to false. So okay, so if I don't remember. I literally just looked at it. If the length of the primes is equal to n, we break, right? Because this is for like if it's like small primes. Like if n was 3, actually, what is this part for? Because this is what I have here, right? Oh, why did I need this? It's like I can't think of a case where the length of primes would be equal to n. Or why is it in here? Why isn't it upper bound? Because I'm assuming that when I did hungry sequence, this was a modification of the seed to check if primes was equal to upper bound, right? I think. First in integers. I don't know, I'm gonna have to Google it or ask chat. Let's see. What it basically does, it stops the seed after we found n primes. Instead of finding all primes up to upper bound, find the first n primes as long as they're less than or equal to upper bound. Yes, I remember, because this problem, the hungry sequence problem, basically wants the first n numbers, right? The first n primes. So yes, this was just a modification specifically for this problem, because if we find n primes, we are done. Otherwise, we keep going until we find n primes. So yes, we do not need this piece. What we do need, though, is the for loop afterwards with the setting to false shit. So for I in range p times p, then we go to n plus 1 and we increment by p, and then we do as prime p equals, or as prime I equals false. So basically we start from p times p, so we store the current p, we start at p times p because that's automatically not prime since it's a multiple of itself, of p, and then we set that to false, and for every multiple of p afterwards we set those equal to false as well. So this is our seed, right? In fact, I should probably make a special folder for like seed and like my own implementation of just like heaps and data structures and algorithms, stuff like that. Like this is just a seed of Eratosthenes, right? So I need to figure out how my friend set up his thing. Let me see if I can find it. This is turning into a very eventful video where we're doing all sorts of stuff outside of the problems. But it's good learning, so helpful templates, resources. This is a link. What is this link to? Graph Basics. That's not what I want right now. Training, general announcements. Might have been in training. Resources? It's not resources. Okay, I definitely clicked this link before, but I forgot where it was. Let me see if I can figure it out. Search. What was this guy's Discord ID? Oh, I have streamer mode on, so I can't even copy it. I can copy user ID. That works. I just need to make sure I don't paste it. Go here. Just disable streamer mode. This probably won't leak. from no from okay, from specific user, this guy, search. Keyword get no contains has link apply filters. Yes, I remember this. I must enlighten the crowd. Linear seed. Link to Codeforces implementation here. CP templates math. Okay. So I'm just gonna take a look at how he set this up, and hopefully it does not open in my main browser or my main folder. Okay, I did that correctly. Now let's turn streamer mode back on. Streamer mode on. Okay, cool. Got it. Okay. So I'm just gonna create a folder. Templates. Call this Seed of Aristophanes. Erato. It's Eratosthenes. Eratosthenes. There we go. I think that's right. Eratosthenes. Um. Then let me copy this just to make sure I spell it right. .py. That way I have this forever. And then def seed of Eratosthenes. We take in an upper bound within int, and then copy this, paste this, return primes is prime. Stock strings this. Here, let's try to use this first. IE. See if Aristosthenes, and then we'll do like 100 or something. Uh, 2, 3, 4, 5, 6. That's not right. Ah, okay, it's here. Gotta make sure to remove this. Okay. Yeah, fuck solving the problem. We're just going on a tangent here. And then we will docstring this. We'll have chat generate some doc strings for us. Computes all prime numbers up to n using sieve of Aristosthenes. Sieve works by iteratively marking the multiples of each prime starting from 2. Any number remains unmarked as prime. Inclusive upper bound finds all primes in a range from 2 to n. Returns tuple of list int, list bool. Primes list all prime numbers in ascending order. Is prime boolean list. Okay. Copy this over. Don't know what's going on here, but tuple li. I don't like that. Okay. Let's get rid of this. I don't like this. I don't like how it's separated like that. Okay, chat, this is your job. Of course. There, that's so much better. Okay. Well, now that we have this, we can always look back to it when we need it. And then, okay, back to implementing the question, because we didn't finish. T primes, where were we? We have the seed, and we basically just iterate through until we hit a number in the seed, right? Have our primes, so for what's the best way to do this? We could just iterate through. For num in x, uh, what do? We square root it. Root equals int math dot squirt. We gotta import math. Okay, they like I squirt. There's I squirt and squirt. What was the consensus again? Math dot I squirt versus squirt. Essentially the greatest floating always returns int. Often faster. Which one is better to use? 10 to the 12 I square is still safer and more specialized choice. Okay, you convinced me, and it should output int, right? So I don't need a typecast. Math.I squared. Although I can just ask my Python guy. I don't know why I'm doing Googling. Yo, when do you use okay. We'll see if he responds to me by the end of this video. But this video is gonna wrap up soon anyway, right? We've been recording for an hour and a half. But okay, so our root will be math.I squared, and then we just check if root squared, if root or we can just do root times root is equal to num and is prime root. Then print yes, else print no. Okay. It broke. It's over. Oh, num? Yeah, okay, there we go. Hopefully this works first try. Put a lot of work into this. Oh, it's over. Runtime error. On test 2, so it passed the test. And it fails the test? Line 22. Index out of range. Index out of range. Index out of range. Oh, this is important. We made is prime n. N is just the length of the array. Not, so we want to make n 10 to the 5. Da 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 about your bed. Da, 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 da. Texas to LA. Hey, hey. Texas to LA. Okay. We just replace N with cap. Why am I printing two things? Oh, I should be printing two things. Yes, yes. Okay, this is expected behavior. So let's submit. Wrong answer on test 3, Jesus. Please, have mercy on me. Wait, what? Huh? Uh-oh, site's breaking. No, okay. Oh, is it 4? Is it case 4? No, yes. No, 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 no. Yes, no, no. When it's 1. 1 is no, because 1 is only 1. So we can simply add in like this. Dude, okay, figuring out these edge cases or just like thinking of them is so hard. Like, I feel like for the past 3 days I've struggled with edge cases. And the site's dying. It's over. It's FF at this point. Gone are the days where I finish a problem in one submit. Now I get a runtime error. Bro, please, let me go. I got stuff to do. I hate dragging out videos this long. I'm sorry, guys. What is this runtime error? How can we speed this up? Uh, well, is it the same idea as those the whatchamacallit, the visor problems that I did for that one contest? The what is it called? Is it this one? Don't think it's this one, right? No, I remember this contest. Codeforces is dying. No. I gotta complete this question quick. First, no, it's not this. Oh, what am I thinking of? Uh, it could just be a completely different question that I'm thinking of. Oh, I think it's a different thing. What am I thinking of? It might be. It's a bookmark question, I think. If I remember it this clearly, it has to be a bookmark question. Just don't remember what it's called. Okay, favorites. Cut ribbon. Pythagorean theorem. It's not cut ribbon. That's the one we did yesterday. Not Pythag. Easy number challenge. No. It's Jover. I don't remember. I think it was like. What did I do? I did like N. Oh, secret message. Yes, yes, secret message. Like this. Periods. We only have to look up to n square root of n because each divisor will already be looked at. So technically, we can make the seed even faster. Because we can avoid some unnecessary work. Let's see. I can do int 0.5 and then no, we can do something like this, right? This makes it faster a little bit. But it's index out of range. Still index out of range. So line 27. Root times root equals num. Ten to the 5. This has 12. Why? Index out of bounds. So that means my cap is... Oh! Wait, this is 5. This has to be 6. I guess I stole 5 from in. I was thinking the cap was in the whole time. It's just not. It's... The cap is the square root of 10 to the 12, right? So... Okay, I didn't put any expected output. Let's suppose this is yes. Don't actually know. We'll have Codeforces tell us, but what stupid ass error. It just gave us a useless in input. I thought it was the cap, my bad. Oh, accepted. Thank God, this question cooked the fuck out of me. We'll bookmark it. I need to do a day where I just go through all my bookmarked questions. There's quite a few of them that I need to review. I'm glad I ran into this question because it's reusing something that I've learned before. Now next time when I do it, I know. We just set up prime array, we set up is prime, set it to true, multiply it by the cap plus 1, and then we iterate through from 2 to square root of n plus 1, or square root of cap plus 1. If is prime, then append it to p, or append to prime, append p to prime, that's what I meant to say, and then iterate through for each multiple of p, set it to false, so that next time when it loops through and it hits a multiple of p, we'll get false and we won't add that to the array. So then at the very end we are left with is prime, which is a list of trues and falses of which indexes are prime, or which indexes are prime, and then we have is prime, which is just a list of primes, and then yeah, that's the seed. That's the takeaway of this problem. All right. If y'all enjoyed this, oh wait, someone messaged me back on Discord. Let's see. He just said, "I just use squirt IDK." Okay, just use square root then. I guess it doesn't matter. Technically, square root is faster than star 0.5 because we used that in one problem and it just did not cut it. Right, so use math.square-root or math.isquare-root. It doesn't matter. Don't use star 0.5 if you can help it. Like, you can use it lazily sometimes, but if it's a question that requires performance, just use math.square-root. Got it. All right, if y'all enjoyed this video, please like and subscribe. We are like 420 something subs, basically like 75 subs away from 500. If we can get to 500 by soon, that'd be amazing. When is spring break actually? Because I need to get more time to like push out shorts. Shorts are like, I get the most views on shorts, so it like brings the most attraction to the channel. But I need to have time to make them, or else like y'all just won't have shorts, you know. But yeah, so I'm hoping like over spring break I can just put out enough shorts to last until summer break, so that way I don't have to worry about it for the school year. Because like I can pump out 3 or 4 shorts a day. It's not hard. It's just kind of tedious. It's a lot of like reformatting the question, and the hardest part is making sure everything fits within 3 minutes. But yeah, all right, I won't hold y'all anymore. This video has dragged on long enough. It's a 2-hour recording. I did not mean for it to go this far, but yeah, if y'all enjoyed this video, please like and subscribe. I'll see y'all guys tomorrow. Bye.